In Algebra 1, we learned how to graph linear inequalities on the coordinate plane. There were a couple things that we need to recall. One of them is that if the inequality symbol in your expression uses the less than or the greater than symbol, when you draw your line on the graph, you're going to use a dashed line. And that if the inequality was less than or equal to or greater than or equal to, you used a solid line. The other thing we did was we needed to put the inequality in slope-intercept form. And we graph it like any other linear equation. It's just that when we graph an inequality, we end up with a dashed or solid line, and we end up shading half the graph. It was called a half plane. So in this particular inequality, x plus y is less than 4, I'm going to put it in slope-intercept form by subtracting x from both sides. So I end up with y is less than negative x plus 4. The y-intercept is 4, and the slope is negative 1. So I go down one to the right one, down one to the right one, and that's how I'm going to plot my points. Because the inequality is less than, it's going to be a dashed line. Now we have to determine which side of the line gets shaded. Remember that when you have an inequality, on one side of your line, all the ordered pairs make the inequality true. And on the other side of the line, all the ordered pairs make the inequality false. So what we learned to do was we learned to test a point. So maybe you were told in Algebra 1 to test the origin because it's 0, 0, makes it really easy to plug in. So if you plug in 0 for x and 0 for y, is 0 less than 4 true or false? Well, it's true. That means that all the ordered pairs on this side of the line must be true, so that would be the side of the line that I would shade. You may have also had a teacher who told you that less than means under and greater than means over the line. That's okay only if you have first put your inequality in slope-intercept form. In other words, you need y by itself. If you don't do that, then you can't say less than means under and greater than means over, because we ran into a circumstance where if you're given an inequality like this, 2x minus 5y is greater than 10, when you go and solve this, you have to divide by negative 5. And in an inequality, if you have to multiply or divide by a negative, we had to flip the sign. And you only flip it at the end of the problem if you had to multiply or divide by a negative. So notice that in the original problem it says greater, so you might have thought that you could shade above the line, but really when it's in slope-intercept form you find out it's below the line. We also learned about graphing compound inequalities. Remember, we talked about compound inequalities when we were talking about piecewise functions. We're going to separate this into two separate inequalities. So we're going to graph two lines. We're going to graph 7 is less than x plus y, and we're going to graph x plus y is less than or equal to 9. So let's graph each of these independently and start with 7 is less than x plus y. I don't like inequalities written like that. I like to flip them. The reason that when I flip it, it changes the sign is because the quantity x plus y has to be greater than 7. You may have learned it in middle school. There's teachers who teach this concept of the alligator always chomps the bigger number. Well, the alligator is chomping the x plus y, so if you flip it, it better still be chomping the x plus y. Now, I'm going to put this in slope-intercept form. And I find out that y is greater than negative x plus 7. So the y-intercept is 7, and the slope is negative 1. So I'm going to put down one to the right one, down one to the right one, down one to the right one. Because the inequality does not have the line underneath, it's going to be a dashed line. And if I test 0, 0 to see if it's true or false, is 0 greater than 0 plus 7? Well, the answer is no. 0 is not bigger than 7. That means that everything on this side of the line is false, which means your true side must be on this side. Now, let's solve the second inequality for y. I'm going to skip a step now because all you're doing is subtracting x. So you get y is less than or equal to negative x plus 9. So the y-intercept is 9. The slope is negative 1. So you go down one to the right one, down one to the right one. You'll notice that these two lines are parallel. That's because they have the same slope. From geometry, please recall that lines that have the same slope were parallel. So this is not a dashed line, it's a solid line. And if I plug in 0 in place of x and y, is it true or false that 0 is less than or equal to 9? Well, it's true. Well, that means that because 0, 0 is below the line, that means everything over here gets shaded. With compound inequalities, though, we want to know where the shadings overlap. So it turns out that the solution region, the region where all the ordered pairs make both inequalities true at the same time, is between the two lines. What I recommend students do is I recommend that they erase all this stuff over here. What happens a lot of times is when students draw their inequalities and then they graph it, they're shading all over the place. And if I can't tell where the solution region is, then it's not right. They don't have to be linear inequalities. They can be nonlinear inequalities too. Absolute value graphs, those were V-shaped. And if you want to plug that into your calculator and figure out what ordered pairs lie on the line, that's cool. If you want to make a table of values, that's cool. The way that I like to do it is I like to base it off its parent graph. And the parent graph, y equals x, which is this graph. It goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, is going to get shifted 3 units to the left, if you recall this from Algebra 2. If it's going to move 3 units to the left, it's going to look exactly the same. It's just going to be to the left 3. And then, look at the inequality symbol. It's less than. That means that this is going to be a dashed line and not a solid. Now the next question is, where does this red line get shaded? The two regions on an absolute value graph are in the V and outside the V. So let's test a point. Let's test 0, 0, which happens to be outside the V. Is 0 less than the absolute value of 0 plus 3? Well, what's the absolute value of 3? It's 3. Is 0 less than 3? Yes, it is. That means that the shading for this particular graph is outside the V. The most important thing we learned about linear inequalities were the application problems, the ones where we were given a scenario and we had to write our own inequality and then graph it. Now, the thing about these real-world application problems is that they are almost always graphed in the first quadrant. So, Nancy Stone has a small company and has negotiated a special rate for rental cars when she and other employees take business trips. The maximum charge is $45 per day plus 40 cents per mile. Discounts apply when renting for longer periods of time or during off-peak seasons. We want to write a linear inequality that models the total cost of the daily rental C of M as a function of the total miles driven M. In other words, we want to write an inequality that represents the cost per mile. That's what the function notation means. So the cost per mile has to be less than or equal to. Well, wait, where did I get that from? From here. notice that it said the maximum charge. That means they cannot charge you more than this. It's a straight charge of $45 a day plus 40 cents per mile. Oops, that was too many lines on my M. So the inequality is C of M is less than or equal to 45 plus 0.40 M. Remember, function notation is the same as saying Y. Oops. And this is your input X. So if it makes you feel better for graphing purposes, you can change it. But on the next page, we're going to graph the inequality. I'm going to rewrite this a little bit. I'm going to write it as negative 0.4 M plus C is less than or equal to 45. All I did was I took the 0.4 M and I moved it to the left-hand side. I could have written it as C minus 0.4 M. It really doesn't matter. The input into this particular function is the number of miles. The input always goes on the x-axis, and the output is the cost. The output always goes on the y-axis. I drew a giant first quadrant, and this is why. Can you pay negative dollars for renting a car? Well, no. The lowest amount of money you can spend for renting a car is 0. That's because you didn't rent the car. So we only are going to deal with quadrant 1. The other reason that I rewrote the inequality is because when I graph real world equations or inequalities, I like to graph it using the intercept method, where you find the x-intercept and the y-intercept, or in this case it's the c-intercept and the m-intercept. If you want to know where this particular line hits the m-axis, what you're going to do is you're going to replace c with 0, and then you're going to solve that equation. Don't worry that it was an inequality a minute ago. We're going to just pretend like it's not. So 45 divided by negative 0.4 gives, oh no, I don't like that at all. I don't want to be graphing anything there. All right, so I lied. We'll go back and graph this the other way, which is, so this is the same as saying y is less than or equal to 45 plus 0.4 m, and the y-intercept is 45, and the slope, that's like your b, and your slope is 0.4, but it would really help if I knew what that was as a fraction, and it's 2/5. So in order to do this, I don't know what a good way to do this is. Let's see. Maybe I'll make this tens. 10, 20, 30, 40, 50. So 45 will be here. And maybe to find out some other ordered pairs, instead of doing the slope and intercept, maybe I'll, I got rid of these on accident. That's M and C. We'll talk about how many miles we're going to drive. Let's say, well, what if I drive, 20 miles? What's 45 plus 0.4 times 20? It's 53. So if every tick mark is 10, 53 is probably about here somewhere. Maybe I'll do it again at 40, at 60, just to kind of get an idea of what's going on. 45 plus 0.4 times 40 is 61, so that's going to be about here. And I'll do it again at 60. 45 plus 0.4 times 60 is at 69, which is going to be up here. So it turns out I have a graph that looks something like that. It's a solid line because of the inequality, and since it's in slope-intercept form, the less than or equal to means to shade below the line. So it turns out that any ordered pair that lies in this shaded region or on the line is the amount of money that I could pay. So the last thing I want to do is I want to find some ordered pairs that satisfy the inequality. Well, there's an infinite number of those. So I could drive 20 miles and pay about $10. I could drive 60 miles and do $30. I could drive 40 miles, and the most I'm going to pay is whatever this ordered pair is. Any ordered pair that lies on the line or in the shaded region will satisfy my inequality of not spending more than $45 plus 0.4 cents, 40 cents per mile. And that was graphing linear equations. I will do a separate video on how to graph them on the graphing calculator.